In a previous video, we went over making a function out of some code that moves a unit randomly. So I've got the code open here, and this is a little bit modified from what we had when we made the video. It's a little bit better now. It works with some other units besides just ships and subs. There's a unit right here, and down at the bottom, I'm calling this function and then passing in the information for what I want it to do. That's the side, that's the name of the unit, that's the miles away from where its current location, and then these two are the bearing, so it's in a 360-degree circle around wherever it is where you're allowing it to move to. 150 that's the minimum depth of where it would go. So if we run this, it's just moving around the ship. So we made this into a function. Primarily all that did was allow us to easily reuse this code. But that's not all you would want for a function to be. In this function here at the very top, we're returning, and we've gone over that a couple of times. Return, we've just been using it as a way to exit the function. In this case, it's at the top, and it's saying if the side is nil or the side is empty. Basically, if you didn't pass in the correct information, just exit the script because it's not going to work. They didn't give enough information. But there's another way with functions that you can actually return a value so that when you call the value, you could actually be expecting it to do something and send you something back so that you can use that in your code. So we're going to go over that a little bit just briefly with a quick sort of nonsensical example just to show what it would do. And then we'll go over a function that I've written to create random biologics and see how it uses this functionality. So we'll create a function. All we're going to do is make a function that compares. We're going to pass in three numbers. We're going to add the first two together, and then the third number is going to be to see whether or not the first two are more than that. So we're going to create a function, and we're just going to call it is sum more than x. And for the arguments or parameters, I never know whether these are arguments or parameters. We're going to accept three things, and we're going to call them A, B. Those are going to be the two numbers we're going to add together, and then X is going to be the comparison to see whether it's more than that. I'm going to go ahead and put an end down here so I know where the function ends. And so then logic is just going to be an if, and it's going to be A plus B is more than X, and then we're going to do a then, and then we'll close that out. And we'll go back up here. And so if A plus B is more than X, then when we call the function, we're going to want to get a true or a false. So we want it to be true if it is more than X, so we'll say true, and we're just going to return true. And then we'll do an else, and we'll return false. And that's all we need for the function, I think. And down here, we'll just call the function is sum more than x. And we need to pass in three things. We'll say 2, 2, 5. And then we're going to say print. Actually, we need to set this to, for this to actually do something, we need to create this as a variable. And we'll call that y. And we're going to set this variable equal to what the return is of this function. And then down here, we're going to print y. See what it is. So if we run this, 2 plus 2 is 4. It should return as false. And we've got an error, line 6. And it's because I didn't do the 2 dashes to actually make that a comment. And we're getting no back. So I find this interesting. True and false are supposed to be the type of data that is a Boolean, and it's usually true or false. I've noticed in the game that sometimes it's yes and no, and that can get a little confusing. It's returning no up here, but if you test it, it actually is equal to false. But it's a little complicated for what we're doing. Right now, we're just going to have to accept that it's a little weird. So we can go up here and make this equal to 12. 12 plus 2 is going to be more than 5, and it should return yes. So it's returning yes and no. In reality, it's really true and false. So now, what is an example of why you would want to do that? So I'll show a couple of examples, And the second example is going to be the random biologics, which is pretty complicated. So let's see. We'll clear this. We're going to go over to Command Ops, and the down pilot has a couple of them. The down pilot script. So let's get into the script here. And basically, anytime after return in a function, if you see something, that's what it's returning. So whatever is calling this function, get SAR target GUID, is expecting something back. So that one is returning a value. This one doesn't look like it is. It's just doing something. Here's one that I created, a time helper. So the game uses a particular set of time, which is the number of seconds from a specific date in 1970, I think, or maybe 1930. But the events, the trigger times use a different type of time, which is more like milliseconds or something. I don't quite exactly remember what was going on here, but I had to do a conversion if I wanted to programmatically create a time trigger. And so here is just a time helper function. I pass in the game time, and it returns me the correct time in this other, kind of complicated, this other way of keeping track of time. Let's see if there's anything else that jumps out at me. I haven't looked at the rest of this. Yeah, there's a return there, and it's returning nil, or basically nothing. So here I have some code that I've created to create some random biologics. I'm going to skip, there's a bunch of comments at the top there. I'm going to skip those. And I am just going to copy everything here. Definitely not going to try and create this while I'm making a video. It's way too complicated. We'll go back to the game. And we're going to paste that into the console. And down at the bottom is where it's actually calling the function. Remember, the functions need to load before you actually use the function. So you never call the function at the top if you're using the console, because it won't be loaded. Let's see. Up here you have to set aside, and then you need 4 reference points. So I'm going to go ahead and create those. I'm going to define a rectangle. We're going to have RP 4, 5, 6, and 7. And the order that these are in is very important. Has to be clockwise, so 4, 5, 6, and 7. That should be correct. Spacing in miles. How many miles apart do you want the biologics? We'll change that to 50 so they're a little closer together. And let's run it and see if this actually works. Yep, created a bunch of biologics. They didn't really fill up. The goal was to do something that fills up the grid more or less. But there's also some code in here to make them more random. So there's some distance. We'll change that to 0. Distance jitter. Angle jitter is the main culprit. I'm going to change that to 1. Now if I run it, it should be a pretty, yeah, it's sort of a pretty pattern. Let's look at what this code is doing, and this is going to be a fairly complicated but good use case for returning an actual value. So up here at the top, where are we at the top? All of this stuff here is just the different setting up variables for the stuff to pass into the function down at the bottom. You don't have to do this. You could write biologics there, and then you could write in the points there. I just have them declared as variables up at the top because it makes it easier to change them and to know what you're actually passing in. It's easier to see what you're passing into the function if they're sort of spelled out as to what they actually are. If you look at the function code, and maybe I should look at this in the text editor. Yeah, so this might be a little bit easier to see. This is in my text editor, Sublime Text. Up here at the top, these are just the variables. Everything that's sort of grayed out, those are comments with the 2 dashes in front to comment them out. That's not actual code, it's just explaining what's going on. There are 2 functions that are being called. Here is one at the top, place random biologic. This is the actual code that's placing the random biologic. It's just placing one random biologic. This code down here at the bottom is sort of the controller. It's the one that's doing the math, that's deciding that they should be in this sort of weird looking grid. And it's also changing that based on the jitter for miles and the angle jitter that you pass in. The other function it's using that information, but all it's doing, it's just focused on creating each unit. So in order for this to work, they each need to know what unit they've worked on, because the way this works is that this unit is based on where the prior unit is. That was the only way I could come up with to place them in a particular area to control where they were placed, is if I knew where the prior one was. And then I could say, I want this to be at 90 degrees and 50 miles away from that one. Without that, it's hard to tell. It's hard to come up with a schema of how you're going to place the units. Back to Sublime. So what's happening is the first time that this runs, so random bios is the actual function that you're calling with all of the parameters or arguments. Again, I can't tell. One of these that you're calling in the function is the argument, and then the other one where the function is receiving it is the parameter, or vice versa. I'm not 100% sure. And again, these things, whatever this is, angle jitter as I've used it here, is just within the function. It's using that as the variable name. It doesn't have to match what you're passing in. I think that's actually probably bad form, that I'm passing in angle jitter and then using it again as angle jitter. They should probably be slightly different. So when this one takes in this information, it passes in these points again, and we can see where is it actually calling the function above, local new bio, place random biologic, and here it's basically passing the same information in to this function, place random biologic, and there's pretty much the same parameters as what we had down below. What happens is, as this function gets to the end, it's returning something. So there's a couple of places here where it either returns a new bio or it returns a unit to delete. So part of the code is that, let's delete these. And let's move the RPs over. We don't need this ship anymore. We're going to move the reference points over land so that they go over some land. And now when I run it, you'll see that it doesn't place a unit over land. So there should be some units in here. So it's checking the depth to make sure that it can place something underwater. And it's using a placeholder. Again, in order to place this unit over here, I needed a unit to the left of it. And what I did was I placed an airplane there, a Cessna, and I kept track of which Cessnas I placed there, and I deleted them at the end. But the next iteration through, it needed to know what that unit was. So when the controller function, the random bios function, which is what you're calling, this is what's controlling the grid. The place random bios is what's actually creating one biologic. When you create one biologic, whether or not it's an actual biologic or it's a unit to delete, we need that unit's wrapper to get the latitude and the longitude for the next one. So this return isn't an exit. This return is a value, and that value is unit to delete. That's set to the wrapper for the unit that was created. So no matter what the depth of the point is where you're going to create a biologic, even if it was over land, we still are creating a unit in this code. It just happens to be a Cessna. And then we're keeping track of that in a table. We're inserting it, table insert. We have a table already created, bio units to delete. and then we're just passing in the GUID, and then we loop through that at the end. But the important part for what I'm trying to cover in this video is the ability to return an actual value. And when I say a value, I don't mean yes or no or 3 or 15. We're returning the entire unit wrapper for the unit that was created. That way, when you get back down to this one, if it decides it needs to place another unit, which it does if it's early on in the script, it's not until it gets to the end and it finishes whatever the grid is. It's only when you get down to this one, or it's this one. Not 100% sure. It's pretty complicated the way it's looping through stuff. That's when it stops and it no longer needs what the prior unit is. So if this is the prior unit, once it gets to this one, then it's going to exit. And that might actually be in the code. I can't remember. Let's see. Yeah, that's not actually in the code because you don't need to exit because we're using a for loop. So once the loop is done, then the code exits, but there is no hard return in here unless it was something that I did to exit out in case there was a problem. Like if in the prior one that we looked at, if the side or the unit didn't exist, then it exited, and that would probably need to be something like if the side biologics that we're passing in here doesn't work, but I don't think I did that. I'm assuming that the user is going to take some responsibility for what they're doing, and if they get an error, they need to figure out that they're not passing in the right stuff. Okay, so that pretty much goes over the example I wanted to do. There's a little bit more that we can go over in here. This is a pretty complicated script. This took me a lot of trial and error, especially on this loop. So this is a nested loop. There's 2 loops. It would have been pretty easy to say I want to create units in between this reference point and the other reference point, which is in there. And one of the parameters you can pass in is to increase the grid by a number of columns, and I have it set currently to increase it by 4 extra rows and 4 extra columns. That's why it's going past the reference points. Here's the reference points where it was supposed to end, and it's going another set of 4 rows, and then these are columns. So if all you wanted to do was go left to right, you could just count, I want to do that 20 times, and 1, 2, 3, 4, 5. When you get to the end and it's 20, you would stop. This needs to get to 20, and then it needs to know to go down a level, and I'm pretty sure I've decided that's what's going on here, is it's starting at this unit. It actually has to create a placeholder unit on top of this reference point. It uses that placeholder unit the first time to create a biologic there, if the depth is correct, and then from then it is doing some math to figure out the distance from the top left point to the top right point. It divides that by the distance that you want the biologics to be apart, and that's the calculation for how many columns. It also does the math on this top left point to the bottom left point, and again it divides that by the number of miles apart you want them to be to get the number of rows it's going to make. So if you want to make a matrix that's sort of like this, that's columns and rows, you do 2 for loops. The first loop is to create, it gets complicated, I'm not 100% sure I can explain this properly. The first loop is to create the rows, and then the next one's going down the column. And I think the way it works is it says, all right, I'm in column 1, run the rows, actually I'm in column 1, row 1, run the columns code and make however many columns you need to make, and it's counting I through the width divided by the miles. So if this is 100 miles and you wanted one every 10 miles, there would be 10 columns. Once you get to 10, that's the inner loop is done, and the outer loop increments 1. And now I'm on iteration number 2 of the outer loop, and then you go through the inner loop again, however many there are, however many columns it needs to make. And the rows loop increments 1 for every time the columns loop finishes. So the columns is going to run however many times this is, let's say 30. And then the rows loop is going to run however many times that the distance from the top left to the bottom left divided by the miles is. That could be 40. You're going to run 30 times for every column, and then you're going to run 40 times for the row. It definitely gets a little complicated, and it's sort of aggravated by the fact that, once you get over to this side, what you really need to do is change the angle for the next unit. So it starts here, goes down this line, and when you get to the end of the line, you stop running the inner loop is now done, and now you start the next increment on the outer loop, and then you reverse the angle. Since this is using a bearing from the prior unit, up here we're going at 90 degrees. When you get down to here and you go to this one, if I went 90 degrees, this thing would keep going like a staircase to the right. What you want it to do is come back to the left, so you change the angle by adding 180 degrees to it, and then you're working your way back this way going at 270, right? And then you get to here, and you go down one, and now you can't go at 270 anymore, and you also can't just add 180 to 270 or you're past 360, so you have to reverse. You have to subtract 180. And so really what I'm doing is the 180 is a variable, and I'm multiplying it by -1 at each thing. And so it goes from plus 180 to minus 180, plus 180 to minus 180, plus 180 to minus 180. Whew, something like that. Let's delete this. And we're going to do just one silly example and see if it works. Fingers crossed. The top function is the function that actually places the random biologic wherever this second function down at the bottom tells it to. So if we want a different pattern, we can control that in this second part. And so you get down to where the loop is, and here is for I equals 1 comma rows do. And this is the outer loop. And inside of that, here is the inner loop. I'll go over some of what I just said in here. This is the end of the rows loop, and the rows are, for me, are going left to right. The columns are top to bottom. And here's where I have a row angle. The row angle is either 90 or it's 270. So the first time through, I set row angle outside of the loop to 90. Row angle reverse I have set to 180, so it goes back and forth between 90 and 270. And then here is where I reverse the row angle. The first time through, row angle is set to 90. Row angle 90 equals row angle 90 plus row angle reverse is 180, so that's 270. So the second time it's going to be 270, but here I'm already pre-setting row angle reverse, which is 180, to minus row angle reverse, so it'll be minus 180. That'll be on the third iteration, right? First time through, it's above this code, it's 90. Second time through, it's going to hit this at the end of the first time through, and it's going to be 270 on the second pass through. On that second pass, it's going to reverse row angle, and on the third time, something like that. Something like that. It's pretty complicated. I'd done some of this code before as sort of a generative art project, so I'm a little bit familiar with it, but I'm a little bit rusty on how it works. There's a lot of amazing things you can do. So what we're going to try to do is make a spiral for no reason at all other than to demonstrate what's going on here. So down here, this part here, this for loop here is BIOS to delete. So I don't want to change anything there. This for loop is what I'm going to play with. So I'm going to delete something. I'm going to delete the inner loop. So I'm going to get rid of rows. We're going to say we're going to run this 75 times. We're going to make a new biologic at unit GUID. So up here, this up here is the very first unit. We need to create a placeholder for where we're actually going to place the first unit. So that's a placeholder. This is going to be the first unit, spacing in miles. I think we can still use that. Distance jitter. I guess we have to use these same things because that's what the function above is waiting for. This is a fixed angle. I'm not going to want to use that. I'm going to want to use my own variable here. I don't think I have, actually I have row angle. You can use that. And what's the row angle? Is set at 90. I'm going to set it at 1. Boy, this is difficult to do on the fly. And then over here, row angle equals row angle plus, we're going to say 5. How's that going to work? 75 times through 5 is not going to work. We're going to say 4 times 75 is going to be 300. That might work. We no longer need row angle reverse. Row angle is going to be 4. Spacing in miles equals spacing in miles 1. Right. Spacing in miles 1 is a different number because there was a problem. Spacing in miles 1 is equal to 0. We're going to change that to 10. Spacing in miles, we're going to have spacing in miles equal to spacing in miles plus 10 maybe. So it's going to start somewhere, and every iteration for 75 iterations, the angle is going to change by 4 degrees and the spacing is going to change by 10. It's not going to be a true spiral because it's never going to go around past 360 because that would be extra code that I'd need to write. I can't do it while I'm making a video. So that's going to get to 4 times 75. That's going to get to 300 degrees. Maybe we need to make this something that actually equals 360, like 60. And then if I change this to 6, at the end we'll be at 360. Maybe I need to change this to 59, make sure we don't go past. I'm not sure what would go past. So fingers crossed, if I run this, we should end up with a totally different pattern. Doesn't look like it gave an error. But we didn't get what I wanted. I was looking for a spiral. It's because it's not going back to the first unit. The first unit needs to be always the same. Let's see if we can fix that. Because as I said before, it's returning the prior unit. So my spiral isn't working because this unit's based on that unit and that unit's based on that unit. I want them all to be based on that unit. Which means we could probably hard code something. Yeah, this needs to stay set to this first unit here. That unit. Local new bile equals place at unit GUID. Unit GUID equals new unit GUID. Yeah, I think if I comment that out, that's where it's setting the next unit to be the prior unit's GUID. Maybe that'll work. Let's see. We have to get rid of those. No? Really? That's no fun. Didn't like that. Local new bile equals unit GUID. So I can't quite figure out what it is, but this is where you need to do the print statements to see if you can figure out what's going on. If I print the unit GUID that I'm using right here, I'm expecting it should be the same in the loop, but it sure looks like it's changing. And half my problem is I can't see stuff in the console because I have emulate set to true. So I'm going to open up the Lua history log in Snaketail. Today is the 6th. And look at that, they are all the same. GUID, so the starting unit is the same. When I pass it into here, place random biologic, it is using the same GUID as the starting point. And that starting point should be the top left RP. So when I place it, where do they actually go? They go around it. Okay. All right. I see something. It started that far away from there, and it's I'm not incrementing the distance. All right. I did it right. It's just I didn't change the distance. I incremented the row angle. Now I got spacing in miles. But it's not calling spacing in miles. Calling spacing in miles 1. Now, is it still there? Did I delete? I gotta delete everything. Phew. Now I think I need to zoom out to actually see it work. Almost. Yeah. Pointless coding examples. I could almost make a heart. But if I did a check to see when the angle gets to 360 and reset the angle to 0, then I could make a tighter spiral and have it spiral out, which would be pointless in the game, but it's just an example of the way the logic of the two function is working. That the bottom function is the logic for the controller of where to place the unit. The top function is actually placing the unit. Let's see if there's anything else I need to go over. So one last bit, since we're on this never-ending example. Some of this code was stuff I hadn't worked with before. So like I said, in the place random biologic where it's actually placing the unit, we're doing an altitude check to see if it's suitable depth to place a biologic. If it's not, then we're still placing a unit, but we're placing a aircraft as just a placeholder. Since the depth isn't right, I just went ahead and put an aircraft there, and I didn't want to check and see whether it was still water or whether it was over land, so we're just putting an aircraft there. After I put the aircraft there, I do this table insert. And I'm inserting into the table. The way the table insert works is you pass it in a table name and then the thing you want to insert into the table. My table name is biounits to delete, which I set up somewhere. Right there, biounits to delete. It's a table, so it's a set of curly brackets, and the curly brackets are empty. So I set biounits to delete to an empty table. And then if I get to this part where the water is not deep enough, I still create a unit, and then I insert the GUID, unit to delete.GUID. I insert that GUID into the table, and then I'm returning the value of unit to delete, so the next iteration will still know where that unit is. And then at the very bottom of the code, this is where I delete those units. So you never actually see that there's Cessnas all over the place if it's over land. There's another for loop, I equals 1, and then this pound sign and the name of the table. That's the way to get the quantity of a kind of table. From what I've read, that doesn't always work. The table, the way I created it, it does work. So this is a loop for 1 comma the quantity of units in that table. So if there were 15, this would be 1 through 15. And now it's going to loop through. I create a new local variable, GUID to delete. I set that equal to biounits to delete, bracket I, close bracket. This is, that is the index of where you're at in here. So if it's 1, if it's the first iteration, that'll be 1. If it's the 5th one, that'll be 5. That's how you get a specific value out of the table. As I want the fifth pair of things that are in that table. I think that's what it is. It's a 5, and then it's the GUID. I shouldn't say that. So you're going to get the 5th GUID out of the unit, and then I just do send edit delete unit. The GUID is equal to the GUID to delete that I set right there, and then that cleans up all of the units that I created as placeholder aircraft to make it so that I could get the next unit to delete. That's pretty complicated. It took me several hours to create this, a lot of trial and error. Most of the trial and error was on the nested for loops to get the grid right. The actual using the tables, I hadn't actually put stuff in a table that I know of. I guess I have a couple of times, but deleting a series of things out of the table, that was super easy. I got that on the first try. That was no problem. Let's see what else there is in here. Other than just being overly complicated, that's the main things I wanted to go over in this, the return of a value rather than just using return to exit a function.